lunch break, nearly 45 minutes to 30 minutes, we'll just shorten it. So I want to spend much time with you all to show much more things. So, and meanwhile, in the lunch break or even now if you have time, right, I'll share an app in your phones. Okay, the name of the app is Data Dashboard. You did not download it, but I'll just share you, okay, because the latest version I don't think it is available in Play Store. Through a link from NI, you can download it, actually speaking, okay. So I'll anyway share it through share it, okay. If you have share it, you can just switch on. I'll just share it. Not now, I'll do it, in the break hour. I don't want to waste time now. I'll share it to one particular person maybe, so he'll be, trying to transmit to everyone, okay. That will be fine. Yes. Coming back to IoT, okay. So this session from now, it is going to be purely on IoT, how to design IoT, what is IoT, what are the features happening, what is the progress happening in industry, what are the different networks can be used for IoT, what is the actual overview, protocol, architecture of the IoT, everything will be discussed now, okay. On this regard, I want you all to just assemble and settle down fast, so we'll just start up the session, yeah, settle down, settle down. Okay. I'll just move on. I think this is the first one. Yeah. Okay. So, what do you know about IoT, basically? What is meant by IoT? Any application of IoT have you ever seen or thought about it? Basically, what is IoT you believe? What is IoT you believe? Let me tell you what is actually IoT is. It's, bringing multiple non-living things together, okay, tiny living or, non-living objects like, any of the items that is being utilized in day-to-day life, okay. So, bringing them all together closer by communicating them through networks, okay. So, any object that can communicate through network will be falling under the IoT information, okay. So, IoT stands for Internet of Things, okay. So, actually it means things which is connected through internet. That's what actually it means, okay. The reason why they do it is to make our human being life more simpler, okay. So, machines have to take their own decisions, okay. Machines and non-living things wanted to be taken new decisions, okay. So, that will make sure, and this decision will be always favored to human beings, okay. This decisions will always be favored to human beings. So, making your life yet more easier to live. For example, let me say early morning you wake up, okay. The moment you wake up, that has to be sensed by some of your, sensors in your home to do IoT home, smart home, right. So, it will be getting, what is that, checking your, that we are awake or not. You will switch on your geysers, motors, so that, you'll be getting ready for your bath. Okay, and your microwave oven, depending upon your bath, once you bath, it knows that within 10 minutes you come for breakfast. Okay, once you take bath, that will be noted down. Okay, that will be sensed by something, and your food will be ready itself. Okay, once you have the food, it knows that you lock the door and you'll get back to your car and you'll be starting to your office or college or whatever it is. Okay, so immediately you finish your dinner, your breakfast, it will keep your vehicles ready with all fuels filled up and everything. Automatically everything happens. Ultimately you have to just go sit like a king and come back. That's the actual idea of what IoT is actually all about. Okay, so and more precisely coming to industrial IoT, whatever I was trying to talk is the commercial IoT. Okay, there are two different types of IoT: commercial IoT and industrial IoT. Okay, we are actually emphasizing towards industrial IoT. When I say commercial IoT, it's for a particular person. It can be a PAN. PAN stands for Personal Area Network. Okay, it can be for PAN, Personal Area Network, or it can be for LAN, Local Area Network, which means that for a group of people. Let me say there are some handful of people. Let me say 40 to 50 people in this room. Let me say, okay, we want to communicate our things among themselves, my things and your things, if you really want to connect to ourselves. Okay, so then it will be a LAN. I want my own things to communicate them among themselves, then it is a Personal Area Network. Okay, above this we also have something called WAN, Wide Area Network, which means that multiple departments, multiple area, or for a higher area range will be going for a WAN. Above that, if you really want to go, okay, you have to go for cloud computing. Okay, above that, through internet, if you want to connect, you have to go for cloud computing. Okay, so we'll discuss everything in detail. Okay, so first of all, let me just show you how to understand what is IoT. And I think most of you would have figured out what is the components of IoT. Okay, you should have figured out, maybe by this time you would have figured out what is the component IoT. Let me list out the components of IoT. Basically, it has to be your device, the thing, okay, IoT, the T stands for thing there, the thing which actually consists of your actuators, sensors, processing, embedded system, everything comprised internal to it, okay. From your device, it will go to your network, Okay, from your network, whether it is a commercial or it is going to be industrial, depending upon it goes to the internet. Okay, from internet it will go to the backend service. When I say backend service, it can be something like, I mean, recording purpose, documentation purpose, your database purpose. It can be anything like that. Okay, fine. So this is what I was trying to say. So first thing comes your thing. The very important one is your thing. Okay, without thing, nothing can be working here. Okay, when I say thing, there are three things you have to, think about that. So very first one is your sensors and actuators. Okay, the sensors and actuators, that's what we are trying to work on. I mean, till now, that's what we are working. Okay, following that, you have some processing, like, I mean, you can do something like amplification of your signal or filtering of your signal, isolation, and many processes we have, right? Any of the processing technique is needed, or even calibration, conversion, everything will come into picture. Okay, so you acquire the information, you process it, and you will be allowing it to do communication. Okay, so this will be installed into each and every item. Okay, each and every product which you really have. Okay, so this information of your sensors, process, and communication will be installed into your hardware, any object you are trying to work. Okay, so basically it acquires, it processes, and communicates to the local area network. And this communication between them, should be wireless. Okay, so you can't wire each and every object to your network. That is not at all possible. So this has to be wireless. That's the reason this entire thing is actually your MyRIO. This entire thing will be your MyRIO. This thing is actually nothing but your MyRIO, which has sensors and actuators. It can also do the internal processing because it has RT, and it can communicate through Wi-Fi also. Okay, that's the reason MyRIO is considered as a component of your IoT. But actually, MyRIO is not the IoT. Okay, MyRIO is a thing which is installed on your IoT. Okay, so which means that every object you have, you should install a MyRIO to it. If you think about that, right, it is little big hardware when it comes to small materials. Okay, this can be more in the future. It can be more precise, made more compact, like a very small chip maybe. Okay, so you can just connect it to it, and that chip will be serving only one particular application. Not like MyRIO, it serves many things: digital in, digital out, analog in, analog out, pulse width modulation, PWM, everything. It tries to work, right? Encoders and everything. So in this regard, this will serve as your MyRIO. Okay. Following that, you will go for your LAN area. LAN stands for local area network, which means that from here it goes to my network connection, the local area network connection. Okay. From here it will go to your internet. This basically called as cloud computing. Okay. From here it will go to the backend services. Backend services is nothing but it's like your remote analysis. Okay. Then like your database analysis and everything will be coming into picture. Okay. Even here you can say business data analysis and user access and control, remote service, everything will come into picture. Getting it? Yes. So depending upon whether you want to do a commercial IoT or industrial IoT, this component will be either missing or be available. Okay. If you are trying to do a commercial IoT for yourself, for your institution, for your own benefit, okay, you'll have things, you have local area network, directly you'll jump to your backend service. Backend service can be for anyone. Your personal also can have records of everything, so this will be there. And we'll not be working much on this in this session, okay, because it can be anything. So personal use, it can be anything. We will not be concentrating much on this. We'll be concentrating only on these things, okay. So this thing I think I have covered, okay. So from yesterday, this is what we are trying to do. So how to acquire from a sensor and actuator, processing, and also your communication we are trying to see. Communication will come to it. We have not seen that. We will come to it, okay. So then we have to go for LAN. Okay, usually these LANs can be, you can see that it is wired, wireless, or it can be LAN, PAN, or BAN. Okay, so basically it can be wired type. Usually it is not good to prefer wired type. Okay, usually. Okay, basically it is fine to go for wireless. It can be personal area network or a wide area network, or even sometimes it can be your LAN. Okay, so local area network. Okay, so following this will be going for internet. This internet is actual procedure of cloud computing. Okay, so how to push this into your cloud, into a web server. Okay, how you push it in the web server. Through web server, anyone can be accessing it anywhere. Okay, that's what it actually means. Okay, fine. So this will be there. Okay, and what I'll do is I'll move to the next one. So since we have already worked on things, okay, already we worked on things. I'm just skipping this. We will come to this later to communicate. We'll see. I'll show you anyway. I'll just directly move to LAN. How to select a LAN? What are the different types of LANs are available for IoT process and everything we'll be discussing right now. Okay. So just let me know if I'm going a little faster, because this theory session I don't want to spend much time on theory. I want to spend much time on hands-on. So that's the reason I'm trying to finish this as early as possible. Okay. Fine. So when I say your LAN network, it is going to be something like your sensors and actuators will be communicating. These sensors, multiple sensors, you can see these are sensors. This symbol says it's sensor, okay. Multiple sensors will be communicating through wireless sensor network. Okay, actually NI also have, apart from my RIO, let me tell you, this is not the first IoT module from NI. Okay, actually there is something called as WSN, which was launched in the earliest of, later of 2000 version. Okay, what I say is around 2006 or 7, I don't know exact year which was launched. Okay, so from that year we really have WSN from a long back, which means that from 2000 plus year only, right? 2001, 2002, right? From there only we have WSN. Okay, so WSN are actually used for this purpose. So WSN stands for wireless sensor networks. Okay, you have multiple nodes, multiple sensor connectors to it, and even that works with a specific range through antenna. Okay, so it works in specific range. So that will allow it to do IoT also. Okay, so this is the second hardware from NI that is also doing it, but this hardware is more powerful compared to a WSN. Okay, this is more powerful, and it also has embedded system, whereas WSN doesn't have embedded system when it came up. Now they have included some for RIO you can have a WSN. By this mean they have included your IoT through WSN also. Okay, what I mean is for your RIO they also attach one external Wi-Fi kind of feature through WSN. Okay, so your entire big RIO, a C RIO also can work as a WSN. Okay, that's why they have tried doing it. Okay, so let me not be more specific on that. Then you have a gateway. Okay, so gateway is nothing but it's like a server. Okay, so from nodes it will go to the gateway, the server. From server it will go to either to LAN or through internet it will go to your business. Your end services. These are end services to computers. It's coming up either through cloud. It will go to the anybody in any far region, or through LAN it will reach the people internally. Getting it? This is an overview of a LAN connection. What you are trying to establish in IoT technology. Okay. Okay, let me talk about the different types of Bluetooth, IoT technologies available. Number one, the very known communication procedure or protocol we have is basically Bluetooth. Okay, you have used Bluetooth for many years now. From the day we had phones, right? For data transfer, file transfer, we have been using Bluetooth. Frankly speaking, Bluetooth was not actually established for file transfer. It was established only for the connection purpose, but we use it for data file transfer. Even there, if you see, right, a small file to be transmitted will take some lot of time, because the reason is because of the data rate. Okay, at a maximum, this is a smart Bluetooth. Okay, this is a smart Bluetooth which we have. Okay, that is being 1 Mbps. Okay, so before it the previous versions, that was not this fast. Okay, so data sharing will be little slower. Actually, these are all termed as IoT networks. Only for the connection purpose. To make a connection purpose, you'll be using it, not actually for file transfers. Okay, so but we use it, but still we use it, but they are not more efficient when it comes to a file transfer. Okay, so you can see they work in 2.4 gigahertz, and the range is going to be 50 to 150 meters only. Frankly speaking, in a closed network, right, it can be even better, but 50 meters, I think it is little reduces the speed of your Bluetooth. Okay, so Bluetooth is one, commonly things which are being used for a long time by at least Indian people. Okay, we people have used it for a long time. Okay, other people have moved to different things, but we were sticking to Bluetooth for a very long time. Okay, then Zigbee. This is one of the things which we took it a little forward. So Zigbee is one thing we will be using on projects. Usually when it comes to projects and communication phases, we were using Zigbee. Zigbee actually has extra range. Okay, the range was pretty better than Bluetooth. 100 to nearly 50 to 100 meter actually speaking, but even it works in 10 to 100, but the best Zigbee which is produced can give nearly 100 meter range. Okay, but the data rate you can see it is only 250 kbps. Okay, and the frequency range is exactly same as like your your Bluetooth. Okay, so one advantage of a Zigbee is you can design a complex network with your Zigbee, and it is actually, I can see it is developer friendly. I always believe it is a developer friendly, because the amount of codes and amount of effort you try to put for Zigbee to configure is little lesser compared to Bluetooth or any other device network, I believe. Okay, so and also you can nearly connect much nodes compared to your Bluetooth. Number of nodes you can connect will be much more compared to your, I told you, right, number of items you are going to use. On the very first slide I showed you. Okay, these are the nodes. Okay, these are the nodes we are having. Okay, number of nodes matters because we are going to install this IoT technology on each and every object. Okay, so number of nodes should be more for any of the network you are trying to work. Okay, on this regard, Bluetooth connects to a very less amount of network, whereas this connects to a more number of nodes. Fine. Yes, and also it is high secured and it is robust and it is reliable also. Okay, so when I say robust, it means that it is more efficient. That's what it's actually called as robust. Okay, so I'll move to the next one. So these two actually you are more aware of this. Okay, from now I think except Wi-Fi, everything will be pretty new to you. I'll just try to introduce everything. The next one is Z-Wave. Z-Wave actually is little far better than other modules. The reason is this can connect to, in a single network, it can connect to 232 nodes. Okay, it can nearly connect to 232 nodes, and you can see that it is a frequency range of 900 megahertz, which works in a different frequency range, and the range is nearly 30 meters only. Okay, but the data rate, you can see it can go for nearly 100 kbps. Okay, so this is one thing which is little famous, not in India. Okay, it's not in India, but in Europe and everywhere it is little famous, and they have tried installing it in many places. Okay, in Europe they have installed in many places. We usually try to stick to Bluetooth and Zigbee, but in European, if you see, they try to stick to Z-Wave. Okay, Z-Wave is one of the basic networks that will be used outside India. Okay, so like they use even Bluetooth, but somewhere they consider Bluetooth and Zigbee is outdated. They actually use Z-Wave. We don't have any much access to Z-Wave in India. Okay, so on this regard, we will not work much on Z-Wave, frankly. That's the reason I'm just skipping not much on this. This is my personal favorite, 6-LoWPAN. Okay, so 6-LoWPAN is actually my favorite. So you can see that 6-LoWPAN actually works with, the 6 actually means it's going to work not with IPv4. Your computers and everything, you can see that IP address is IPv4 address you actually have. Okay, Internet Protocol address. Okay, this one actually, when it comes to this network, everything will be converted into IPv6. You'll be working with IPv6. That's a huge difference between IPv4 and IPv6, which I'll be covering in upcoming stages. Okay, you will understand that when I try to cover it, IoT will surely prefer IPv6 only in the future. IPv4 can never be used for your Internet of Things. IoT cannot use in the future for with IPv4. You have to go for IPv6. At least for that reason, this is my favorite. Okay, this is my favorite. And coming to this, you can see that the range is not applicable, which means that it can connect to any range. Okay, the range, it can be of any range, and the data rate can also be increased to any level. Okay, the reason is this can operate in the adaptable frequency range. So depending upon the frequency range which is available, like white space and everything, this can adapt its frequency range. Okay, at least for that reason, your IoT sector itself is going to be dominated with 6-LoWPAN personal area network. Okay, so actually it stands for low power wireless personal area network. Okay, and as the name itself suggests, it's only low power. It consumes less power. And coming to your power wise, you know your phone has batteries. Trust me, your phone is one kind of IoT. Frankly speaking, your phone is one kind of IoT. Somewhere you have reached the IoT technology to some extent. Like you worked in, what is that? Kind of Ola cabs you use, Ola cabs. Okay, there you can see that smart billing system, automatic billing system that will be directly coming here. You can send your feedbacks to your phones and everything. Okay, you also have internet banking and everything, which is actually a kind of IoT system. To some extent, they are IoT system. Okay, in this regard, at least the backend service is IoT. Okay, backend service is actually IoT, not the real system I'm talking about. Okay, so GPS is kind of IoT. Okay, GPS and location tracking and everything is kind of IoT here. Okay, in this regard, right, your phone actually consists of your IoT already. Okay, but do you see how much charge you spend on your phone? Okay, every day how many times you charge your phone? At least twice. I usually charge twice, sometimes even thrice. You can see always it will be connected to an external laptop. Okay, so I'll keep charging it always. Okay, because the amount of data I use is more. Okay, think about, this is the only IoT system which is merely IoT, not actually IoT. Okay, merely IoT system which we have in our hands in present age. We are charging it 3 times a day. Okay, so think about, if you are having IoT in every object, is it possible to charge every object 3 times a day? Literally not possible. Logically, it's not at all possible. Okay, so you have to find out some solution that is going to be low power consumption. Okay, especially network, even things wise. This is basically thing I'm talking about. Even actually speaking, you think RIO is efficient hardware, power consumption wise? I don't believe. The reason is every time you have to keep it charged. Every time you are connecting to a process, your socket. It should be in such a manner that you should come out with an internal battery that will stand up for at least 1 year. At least 1 year, you will be replacing the batteries for this IoT technology in your application oriented. Okay, so it has to at least have a standby of 1 year. But actually speaking, there are some hardware that is possible to do it. I'll come to it later. In depth, when we go it, you will understand. Okay, fine. So actually speaking, personally, this is my favorite. Okay, the reason why it is my favorite is two things. One is it is because it uses IPv6. I'll tell you why IPv6 is more predominant compared to your IPv4. I'll be discussing that in later. That's one reason. Number two, it is low power. Low power efficiency is really needed and everywhere. Okay, and actually speaking, your 6 low pan is already being installed in Europe and is being successful. Okay, it has been installed and IoT is being employed. Only in India we are not, started working with IoT in commercial purpose at least. Okay, but in Europe, UK, and at least 10 countries in Europe have installed this 6 low pan, and they have successfully come up with IoT technology. Getting it? At least for this reason, this is my favorite. So in the entire list, this is my favorite. If I would suggest, any of IoT network, I would always suggest low power one. Okay, coming to thread. Okay, so actually speaking, excuse me. So unlike, same like your low pan. Okay, thread is also little more feature, same features involved. You can see the range is not applicable and the data rate is not applicable, but the frequency is fixed frequency of 2.4 GHz. Okay, so you can't change it. Actually, this is a little complex networking system. Okay, which actually involves, you can see it actually involves IPv6. 6 low pan is already internally used. Okay, so this actually one advantage of this one is this is more robust. Okay, compared to your 6 low pan, right? So compared to that, this is more robust. Okay, at least for this, thread is good, but thread consumes yet more complex networking systems. Okay, but this can connect to many more nodes comparatively. Okay, this can connect to many more nodes comparatively. The nodes you can connect, much big IoT system you can develop. Okay, that's the idea. Okay, so coming to the next one, this is our country favorite, not my favorite, our country favorite, not only our country favorite, most of the developers favorite. The reason is, because of its high efficient network. Actually speaking, the network in the sense, the signal range. Okay, within the given range, trust me, this is going to work very fine. Okay, so it's very, very reliable and very, very robust when it comes to your approximately 50 meters. Yes, approximately 50 meters it works. The Wi-Fi range what we have. Okay, so it works. But the problem is number of nodes it can connect is less, and installation cost is huge. Trust me, the installation cost is very, very, very huge when it comes to Wi-Fi. Now, every month you recharge. How much you recharge? That matters, right? So every month, let me say they recharge for 10 GB in an office or a small scale industry. Let me say they recharge for 10 GB. That costs them more, and 10 GB is a very limited amount of data to surf. Am I right? So for industry, for a single person, right? For personal use, 10 GB is sufficient enough and more than enough. Okay. And when it comes to industry, that is not sufficient at all. We are talking about industrial IoT, where Wi-Fi is now being used. As of now, we are being used, and RIO also works on Wi-Fi only. Okay, that's why I have to say that RIO also works on this Wi-Fi only. But the thing is, it works in 2.4 GHz and 5 GHz bandwidth only. And you can see that currently we are using only 802.11. This is what we are using. Even in RIO, that's what we are using. And this can, at the maximum, it can go for only 1 Gbps. Okay, at maximum. Okay, but currently, if you see in your home networks and everything, maximum we will get only around 500 Mbps or something. Maximum. Okay, 1 Gbps on special cases we will be getting it. Okay, but the disadvantage is it is approximately only 50 meters of range, which means that it is edible only to make a LAN, not a WAN, or not actually for cloud computing is not sufficient. Okay, and one more disadvantage is high power consumption. Every time you have to keep it charged. Okay, every time it has to be charged from the power socket. Okay, and one more thing is it is high cost effective also. Every month you recharge and everything, right? That's a little cost effective also. Okay, coming to the next one. Any doubt in this? Wi-Fi? Fine. Coming to the next, cellular. This is one widely used network also. Your phone networks like Vodafone, Airtel, everything whatever you have, right? So on that regards, right? This basically at a range of 35 kilometers maximum. That's huge. Okay, that's a huge network range. And you can see that the standard is basically GSM, GPS. These things are actually supported. And nowadays we are coming with 3G and 4G also. 2G, 3G, and 4G. And frankly speaking, this is one of a very fast network available. Very fast network available. Very robust. And robust means very reliable. Okay, very reliable. But one problem is cost effective. Very, very, very cost effective. Now, at least nowadays we have Jio, we are surviving somehow, We can't, depend on Jio for a long time because he will, Ambani anyway, he'll go on a cut short his, all the prices anyway. Someday is gonna increase it. We have to stick to normal prices only. Usually the normal prices used to be 300 rupees or something for 1 Gbps, or for 1 GB or nearly 2 GB we pay around 300 rupees. Think about each and every object you have to recharge for 300 rupees every month. That's literally not possible. No, so it's very cost effective. Okay, cost consumption. Not effective. Okay, so at least for that reason, this one thing which consumes lot of investment cost, and even setting up towers and everything in a specific range, and many people are connecting. Number of nodes connected is very less. Number of nodes you can connect is very less. Actually, if you see your BSNL, right, at a time you can only connect 10 networks. Do you know that for a tower, okay, only 10 people can connect to a tower. So very less number of nodes it actually connects. Okay, so at least for that reason, cellular can be more reliable when it comes to networking only. Okay, sorry, when it comes to your normal phone calls usage only. When it comes to IoT, I don't think so it is going to be successful. Okay, so I'll put to the next one. NFC, surely not IoT module. Okay, NFC is actually, the name suggests, it's near field connections. Okay, so it stands for near field connections. Basically what it does is like your RFID. Okay, for biometric kind of thing, you try to put your RFID and you try to move in, right? And for transaction purpose also, right, we try to use that. Okay, so the range is very less. It's only 10 centimeter. You know what is 10 centimeter? This much gap, nearly very small gap. Okay, so it's a handful of gap. Okay, the data rate is going to be nearly 100 to 420 kbps. That is sufficient enough to do your like cashless payment, your ticketing. Yes, these things are fine. Okay, for these things it's fine. Like security purpose, yes, these things are fine. Okay, but for IoT, I don't think so. It's fine. Okay, very short range, very short range. Okay, fine. Coming to Sigfox. Okay, Sigfox is one of my favorite. Let me tell you about Sigfox. So Sigfox is actually, it's nearly 30 to 50 kilometers in rural and nearly 10 kilometers in urban, and you can see the speed is little less. It is only 1000 bps. Okay, bits per second. Okay, so this works in 900 megahertz. But one advantage of Sigfox is, once again, developing is pretty easier. As a developer, I know the pain I'll go through to develop these things. Okay, to develop IoT system and everything. So ultimately, right, this is little comfortable when it comes to a developer, Sigfox. Okay, Sigfox is also one of the brand which is successful in Europe and US. Okay, very successful in US and UK especially. So they actually use much on your IoT technology only. The reason why this is more successful is, number one, it is less power consumption, very less power consumption. Trust me, it's how much less power consumption is. This network consumes very less memory. That, do you know, two AA batteries, 2 cross AA batteries. Okay, so this can supply nearly 20 years with that battery. Okay, think about that. Just such a big batteries you have, right? Like big batteries. Okay, not a very big batteries, not MAH I'm talking about. Okay, so AH, normal AH. Okay, AH batteries, small batteries. Okay, this can survive for this network can consume only less memory. Power in such a manner that it's sufficient for 20 years nearly. Okay, and also the watts they consume. Your cellular actually consumes nearly, this consumes power-wise very less power it consumptions. Okay, it consumes. Okay, it's nearly 10 times lesser than that. It actually consumes, for example, if your cellular is consuming 5,000 or 50,000, microwatts. Okay, this will be consuming only 50 watts or 50 microwatts. Okay, at least for this reason, this is more successful in other places. I'll tell you one thing: if you want to really go for IoT, the one which will be going to be more successful is the one which is less power consumption. Okay, the one which has a high battery backup. Okay, so actually speaking, your Sigfox is one kind of that. Okay, Sigfox is really successful. The reason is it's very less power consumption. Okay. Coming to Newell, frankly speaking, I'm not actually very much fond of Newell. Okay, so Newell, one advantage of Newell actually speaking is the data rate. Okay, so data rate might be from few BPS up to 100 kbps. Okay, but this can work on white space. How many of you know what is a white space? Do you know what is a white space? Okay, white space is nothing but many people might transmit many information. For example, your FM range, right? What is the FM range? It will be in 91.5 or something like that in megahertz. You'll have it. Okay, so that is the range is always occupied by one station. Okay, so they transmit and receive everything through that bandwidth. Okay, so each and everyone have their own bandwidth. You know this. None of them will share the bandwidth. The reason is there will be more traffic. It's like a road route. Okay, so everyone start using the same road, it becomes more traffic. So no one can reach on time and no one can, come back on time. Okay, at least for that reason, even your signals will have traffic. Okay, so when you try to transmit in the same frequency every time, that's the reason each and every country has its own frequency bandwidth. Do you know that? Each and every country has its own frequency bandwidth. Okay, India works with one particular bandwidth. Okay, US will work with one particular bandwidth. Military purpose will have a different bandwidth. Okay, actually speaking, in the very first slide, if you see even here, right, it talks about ISM. Okay, do you know what does ISM mean? Yes, it's like industry, science and medical field. Okay, for them this is the range. Okay, which means that they have their specific range. Okay, others are all common ranges. They don't have specific ranges kind of thing. Okay, so coming here, you can see that on ISM it works on this band. Okay, so for UK it works on this specific band. You can see that there is a different band for each and every one. Okay, when it comes to white space, which means that for anybody else it works on white space, which means that it has an automatic smart system that will check for the less traffic in the bandwidth. Okay, so let me say in nearby area, many stations are there. Many power stations are there, or they are transmitting things. Okay, it is all busy. All the bandwidths are busy. There might be one single bandwidth no one is using. Okay, this will search for it. Okay, this will search for it, and that's basically called as white space. If there is a traffic, a bandwidth which is having traffic, that's called as a gray space. Okay, so it will avoid the gray space and it will try to transmit on white space only. Okay, that's the reason Newell is actually really successful. Okay, so this is one of the things which is successful, and trust me, most of the these networks are successful in Europe. Okay, US have their own. You can even see they have special for UK. They are very successful in UK and Europe countries. Okay, so coming to the next one, LoRaWAN. Okay, LoRaWAN is also was a network which is going to be working in 2 to 5 kilometers of range. Okay, that's really fine, but you can see one advantage for our people is it can connect to Raspberry Pi, Arduino and other small hardware too. That's actual more success in LoRaWAN. Okay, they can actually connect to these things, and this one is also less power consumption. Okay, this is also less power consumption. Okay, so because it uses only small boards which can be powered with only 12 volt. Okay, you can power this board with 12 volt, and this can attach a antenna, and you can just try to transmit and receive all the informations. Okay, so these are the things which you really have in industries for IoT purpose. Okay, in which I believe the most successful one will be a Sigfox Sigfox one, which is really successful. And coming to next, your cellular is also kind of successful, but it is not successful in IoT, I believe. It will not be successful in IoT, I believe, because at least for the cost effectiveness. Unless these people reduce the cost, like how Jio do. Okay, Jio, you know how much free data they try to transmit. Okay, so like how Jio do, right? Unless they try to give some free network, right? This is going to be a flop model. Okay. Next, apart to that, Wi-Fi is one best solution for LAN. For LAN area, Wi-Fi is the best solution, I always believe. That's the reason even your MyDay use Wi-Fi. Okay. So coming to next, your 6-span is the most successful one among all the list. Okay. The reason is it is low power consumption. Okay, as the name says, it's a low power consumption, and number two, it is IPv6. That's a very important thing, and also you can see the range and data rate is actually adaptable. Okay, at least for that reason, many people connect. The data range varies. Very less people connect. Okay, the power consumption is less because the data rate is adaptable. At least for that reason. Okay, fine. So these are the actual different types of networks you can prefer depending upon your usage, and we will be preferring Wi-Fi. Okay, as of now for this session and everything, we'll be preferring Wi-Fi. Okay, I'll move to the next topic. Okay, what is the difference between IPv4 and IPv6? This is a very important thing. Usually IPv4 works with 32-bit number. Okay, and when I say the 32-bit number, your information will look like this: 192.149.256.2.776, whatever may be the number. Like I was trying to show you, right? For MyRIO, what is the IP address? Let me see how many of you remember. 172.22. Okay, this is an IPv4 address. Okay, this is the IP address for version 4. Okay, so and you can see number of address you can occupy is, since it is 32-bit number, 2 power 32 is the maximum number. Approximately this is the value you can, or this is the nodes you can connect to it. Okay, these many addresses you can create for it. When you have different nodes, different objects with its own network, each and every module should have its own address. Okay, so when it has, like a computer has its own processor which has its own address, my RIO has its own processor, it has its own address, am I right? Same way each and every object is going to have a processor to it and it will have an address, and in that case this is the limitation you will be having. Number of addresses you can generate is very less. So when it comes to IoT, each and every object is going to have its own address, am I right? So in this case you will be going for IPv6. That's the reason I told you 6 low pan. That was more success. The reason is because of this, it's used 128-bit address, bit number, sorry, okay, 128-bit number, and an example of a address will look like this. You can remember this, I believe. I hope you can remember this. Trust me, you can never remember this. Okay, this will be your future address for each and every IoT items. Okay, and also you can see 2 power 128 will cause these many objects to connect in a single network. These many objects I can connect in a single network. Now, actually speaking, in other words, how they say is, you can connect 2 power 28 or 2 power 30 approximately. Okay, 2 power 30 address for each and every individual in this whole world. Understanding what I'm saying? I can assign 2 power 30 different addresses for a particular individual person, which means that a particular individual person can have 2 power 30 different addresses for his objects. I have multiple objects. Ultimately, we maximum will be using 100 objects. How many objects you use in a day? 100 objects maximum, 100 or 200 objects. But how much IPv6 can accommodate is, okay, it can serve. Serve for 2 power 30 addresses per individual in the entire world. Okay, that's huge in number. Trust me, that's a very huge number. Okay, so that's the actual advantage of going for a IPv6 over IPv4. Right now we are sticking to IPv4, but in future we have to move to IPv6 at any cost. If this IoT is going to happen practically, it has to be IPv6 only. That's the reason I told you that, that's my favorite, 6 low pan, that's my favorite, right? That's only for that reason. Okay. Okay, coming to this back, I think I just gave an overview of LAN connection. Now I'll move to things. Okay, things already we have covered it, but few things you have to remember when you select your thing and what a processor you are using and everything. Okay, so we come to the things. When it comes to things, there are 3 things here are important: sensors and actuators. Number 1. Number 2 is going to be a processing, and number 3 is going to be a communication. Okay, fine. So basically, your thing should be a embedded system. I think I told you in the first. Okay, the reason your thing should be embedded system is you are trying to put a processor and processing should happen on that thing. Okay, don't think about putting a single computer for each and every object. I have a comb, I want to put IoT module for this comb. Okay, I can't put a computer for this. Okay, and if I want to comb, I can't carry a computer and comb it. No, that's not literally possible. So I have to do an embedded system. I have a very small chip which has been inbuilt on that internally. So what happens is even your currency can have chips in the future. Trust me, in your, I think, there are many, rumors saying that your 2,000 rupees note in was launched with, satellite connection, GPS connection and everything. They are fake, but actually in future that will happen, because to track the, black money, right, that should happen, I believe, to track your black money and how much money is being stacked up in a place. To understand that, you can actually go for, your, that IoT concepts, okay. That will be a nice idea to avoid black money, okay. IoT also will avoid, these kind of corruptions and black money, okay. So you can see that home sensors and all the other objects which are using it ultimately should have these things. Sensor acquisition should happen, okay. So actuator control, based on this acquisition you have to control something like how we did, right? So when I bring something I have to switch on the LEDs kind of thing, okay. So you have to control the actuator. Data processing should happen, and also the wireless connection should happen, wireless communication should happen, and power management is very, very, very important, because this is going to be installed into a product, every product, okay. So it is going to be installed in every product, and you can't charge each and every product. That is not at all possible, okay. So you should have a batteries or something which will be inbuilt. So battery life should be always, have a track of it, and you should, at least work for nearly a month or, nearly a few months, 2 years. It should work. Only then it will be a successful product, okay. So power management is going to be a very big crisis in the upcoming year. Wait and watch, okay, if IoT is coming into picture, okay. So these are 3 things you'll be, having to look out. Processor for the thing, what processor you are actually using, okay. There are many processors actually you can prefer. Frankly speaking, there are many processors you can actually prefer. It's up to you, but I always suggest to go for ARM processor, Cortex M0 series. The reason is power consumption, number 1. power consumption, how much power it consumes, and the programming style, and how much it tries to be more robust and everything. At least for that reason, for your IoT, I always, for your things, I'm talking about things, okay. For your things, I would suggest you to go for ARM processor, which is Cortex M0 series, okay. But if you're going for your gateway, if you're having a gateway, you know what is a gateway? The server, right? If it's a server, I would suggest you to go for, ARM Cortex, M3 or M4 or M5 series, okay. So that will be the edible one. If you feel like you don't want to go for, ARM at all, I'm not interested in ARM processor, I want to go something else. I'm not here to promote ARM, actually speaking. If you feel like you want to go something else, right, you can go for Renesas, okay. Renesas, you can go for RX 100 for your thing, and you can go for RX 500 for your what is that, gateway, okay. That will be the edible chip processor chips you can prefer, okay. And trust me, when I say you want to go for processor which is low power consumption, right, and actually if you see, next I want to talk about power consumption, which means that there is something intermediate between them, which means that the processor which you use should have a low power consumption, okay, which means that you should try to design some transistors which are going to have a very less threshold frequency, okay. So that is like a trade-off, okay, like a trade-off. When you try to go for less voltage, threshold voltage, right, you come up with many problems, okay. So at least it's going to be a trade-off. So that's the reason I believe that ARM, which is really good in that, okay. ARM, especially Cortex version, I feel it's really good. Actually, your MyRIO also use the same, but not M series, okay. M series is a very famous series from ARM, okay. It's a very successful and famous series from ARM, but this uses Cortex 7 version, okay. But somewhere more or less same, but Cortex is really good, but Cortex M is top of all, okay. Okay, coming to programming language, we are using LabVIEW, okay, but I don't think so. LabVIEW will be, more preferred programming language when it comes to universe level, okay. The reason ultimately is we want IoT to get, implemented in each and every domain as early as possible, okay. To just count the number of LabVIEW developers we have in India. In India, we have around only 180 CLDs, okay, 180 to 190 CLD certifieds we have, okay. So when it comes to, Java, worldwide we have 90 million Java developers, okay, in worldwide, okay. Java developers we have 90 million, okay. And when it comes to C++, we have nearly 4.5 and everything, okay. And when it comes to Oracle and ARM and everything, right, they nearly have around, 4.5 billion developers over the universe. Okay, when you try developing with them, frankly speaking, compared to LabVIEW, if you try developing through them, the success and the progress is going to be very faster. Okay, but one advantage when it comes to LabVIEW is the programming style and skill is more efficient. So with less number of employees only, we can actually achieve the target what actually Java or something doing. But one problem with Java is Java actually works with the top level of your OS. Okay, actually Java works with the top level of your OS. So there is no question that you should either use C, C++ or Java. No, there is no question like that. You should ask a question whether I should use Java or I should not use Java, because C and C++ should be there. Because to the core level for the process, C will be working. Java is a top level version of your OS. Okay. Coming to LabVIEW, even that's the same question. Okay. So LabVIEW is actually a top level like Java. Okay. So coming to Java, backend should be C or C++. Coming to LabVIEW, backend should be C or C++. So anyway, but user-friendly program and application development should happen either in LabVIEW or in Java or any other toolkit like that. Okay, but there are some problems and you will face when it comes to Java. Okay, so that's the reason. Everyone are trying to prefer LabVIEW across Java. Okay, fine. So things. Okay, so basically, and one more thing I want to say. Java basically, to install your, information, deploy the information to your RTOS, okay, to your RTOS, right, to install it. It will not be, much, the footprint, the memory footprint it will leave is going to be more. The amount of memory it is going to consume is going to be little more when it comes to Java, okay. That's one problem you will be facing. Fine. So coming here, okay, let me make it a little faster. So you can have processor, 16-bit processor for sensors and actuators with a power supply inbuilt. And coming to this is for your communication purpose. You can have a separate processor for 32-bit. Okay, so which means that in your thing you will be having two processors. Processor number 1, processor number 2. Processor number 1 will be for sensors and actuators. Processor number 2, and this will be taking care of your all your processing and everything. Okay, so acquisition and processing will be taken care by this processor, and whereas your wireless communication and everything will be taken care of by this. And you will be having different power supply. This has to be a 16-bit and this has to be a 32-bit. Okay. The reason why it is 32-bit we are actually proposing now is we are all using IPv4, which is 32-bit processor. Okay, I mean 32-bit name. Okay, when we go for IPv6, then we can propose something better than this. Getting it? Yeah. Okay, gateways, fine. Gateway is nothing but, let me tell you what is a gateway. It will collect the data from local network and transmit to the internet, or it can be a wide area network. That is all it is. Okay, it's a gateway through which all the data will be passing through. Okay, so if you see here, you can see the Bluetooth, Zigbee, and then Wi-Fi and everything. It collects the information and it passes through where? Satellite and then other, universe, other, external world for internet purpose. Okay, ultimately what this will having is switching and routings will have. Like, the normal servers we talk, right? So talking about the servers, protocol conversion, firewalls and VPN, and also we have security with a processor internally placed. That is all we have in a gateway system. So gateway is nothing but, how to say this, I actually acquire information. Okay, I'll put it in such a way to make you more understandable. Okay, let me say I want this entire universe to be connected in a single network. Let me say, okay, I want this entire, or let me keep it pretty simple, not like that. I want, entire Vijayawada to be connected in a single network. Okay, I want to do a smart city, smart city, right? I want to design a smart city now. Okay, I want entire Vijayawada to be connected in a single network. Okay, so let me say I have Vijayawada. Okay, so I have to subdivide it into multiple classes, only then I can communicate. Okay, so we have a main server here. Okay, so let me say I divide into 4 groups. Let me say direction, north, east, west and south. 4 directions I have. I just put into 4 places. Okay, so this will be the subdivision headquarters. Okay, so once again if you see, let me call different colleges here. I have around 10 colleges here. I have around 10 colleges here, 10 colleges here, 10 colleges here. Okay, each and every college will have multiple departments. Okay, every department will have multiple labs. Every lab will have multiple instruments connected. Am I right? Yes. So this multiple instruments will be communicating to this particular departmental server. Okay, this is a gateway for this network. Okay, so this will act as a gateway for all these networks. This will act as a gateway for all these networks. This will act as a gateway for all these networks. This will act as a gateway for all these networks. Getting it? The main router is basically called as excuse me, will be called as your gateway. Okay, that's what it's actually saying. It will do the basic wireless communication in LAN and transmit it to the internet through satellites and all the database management systems for backend services. Ultimately it has only one thing, switching and routing. So it has multiple things considered under it, so it will switch and route it. Okay, then apart from that, protocol conversion will happen. Okay, and apart from that, firewall management and security system should happen, because hacking will come into picture in this monotonous world. Okay, at least for that reason, security should also come into picture. Getting it? Yes. So let me not make it. Okay, this is the web service. The way we use the internet, the human people, what we use the internet, right? So we connected through www. Yes, World Wide Web. We will be communicating through that, and actually at the base we will be having TCP connection. Okay, and IPv6 will be using. Okay, you can see here for Internet of Things, what will be the base? What will be the base? Will be 6LoWPAN will be the base. Okay, this will be the base, and you can see that it will be using UDP. When I say UDP, you know what is UDP? User datagram protocol. Okay, that will be as a base for it, and that is going to be the actual, the way we communicate through network and way internet will be communicating the network will be of a different architecture. This is actually like an architecture I'm talking about. Okay, this is the architecture, it will be fine. This will be happening. Getting it? So this will be playing a vital role. And coming back to cloud, okay, so this is little easier to understand. Fine. So these things, whatever we use in day-to-day life, that can be either, a personal area network or local area network, I told you. Okay. So things what we use, this will be personal area network or local area network. From there it goes to the hosting devices. When I say hosting devices, what it means? What is hosting device? Sorry? Just now I told you, right? Just telling about this. What is this? Your gateway. Okay, this will act as a gateway. Okay. From gateway, Okay, from LAN gateway, it will move to the WAN gateway. Okay, WAN devices, wide area network. This is what I was trying to say you. Okay, so local network to the main network, from there to the main server. Okay, so from here it will go to the HRN interface. HRN interface is like, for internet purpose and everything. Okay, so there it goes to the records and services for backend service. Okay, for backend service it goes. So it's like subdivisions. Okay, from how the data are going to flow to the cloud. Okay, that's what actually it is talking about. So this is the last thing I want to introduce to you. Why to go for RTOS? Why not to go for Linux? Okay, frankly speaking, real fact about Linux is one of a very successful OS when it comes to your embedded system. Okay, it's a very successful thing which comes to our embedded system. Okay, but the problem with Linux will be, for embedded system is successful, but IoT I don't think so it will be more successful. The reason is the memory footprint which they leave. When I say memory footprint, it's nothing but the amount of memory it is going to consume on a RAM. Okay, you know this RAM, which is the Cortex RAM, one of the best RAM available. Okay, so it has only 512 MB. Okay, so let me say, when you use a Linux, deploying a Linux code into this or Linux OS into this consumes huge memory. Trust me, it's going to consume a huge memory. That's why Linux is actually successful when it comes to hardware like computers and everything. Okay, but when it comes to a hardware, IoT thing, okay, where memory should be very less, because power consumption less, memory also should be less. Okay, so in this regard, it can't be surviving in 8-bit processor or 16-bit processor. Somewhere even newly launched 32-bit processor also it can be successful. Okay, so it has to go to RTOS, which is more robust, reliable, and you can even break components into small modules and you can deploy, which means that small program you can deploy like how we do in LabVIEW, right? It's RTOS. Okay, so RT controller, right? So RT controllers should be preferred, and the program you have to use is RTOS. Frankly, Linux is actually successful when it comes to embedded. I really believe it's really successful because at least for the the friendliness what it had for the developer. It's a developer friendly actually. Okay, at least for that reason it's successful in the embedded system. But IoT, I don't think so it's much successful. Getting it? Simple. Okay, if that is done, we'll just directly move to your LabVIEW. Let me first show you how to communicate. I just closed it. I'm sorry. This one. Okay, to this one, as I show here, okay, you can see that sensors, actuators, processing is involved. Okay, following that you have communication. I'm just going to start up with this. Okay, starting with this, and I'll just finish this, and then let's move to backend service to some extent. That what is it? The app which I'm trying to install in your phones, right? That will be like your backend services, like to monitor purpose and everything. Okay, to show you how it is actually working. Okay, so on this regard, shall we start? Is it boring? Yes. We'll just have a hands-on. Maybe more theory sessions will be like that. And trust me, when you try to learn something very new that we have now come across for many times, right? That makes you little not focused. Okay, you'll just get distracted much. Okay, so we'll have a hands-on that will get you back to the session. Okay, so what I'll do is I'll minimize or I'll close everything. I don't want anything. So you're completed with that. I'll even close this. I don't want this. Everything I'll just close. So I just don't want to save this. I'll just close it. Okay, I'll even minimize my LabVIEW, or I can just close it, or let it be. Okay, so everyone have Macs in your there's a software called Macs, Macs, or I'll just start from the first. Just close this. Okay, you can just search for MAX, Macs. That will be available on your desktop itself. Macs. Macs actually stands for, you can say Macs. Macs actually stands for Measurement and Automation Explorer. Okay, Macs stands for Measurement and Automation Explorer. So any hardware which has the ability from any hardware has the ability for measure and automate, that can be explored here. Okay, so I told you on the very first day, don't try to use the Macs, because Macs is for some other reason. That is for configuring your hardware. Okay, so we'll be using that there. Okay, so Macs, once you open your Macs, once you open it, you don't want to do anything. check it whether it is available. It should be available. With basic lab it will be available. Okay. So have you people connected your hardware? Hardware is connected to your computer. Okay. In the computer where the hardware is connected, you can find something called remote system. Okay, you can find something called remote system. This is a hardware where you can dump your code and monitor from the remote place because it has a Wi-Fi connection and everything. Okay, so at least for that reason, this will be falling under a remote system. Your MyRIO actually will be falling under a remote system. So I'll expand this. You can see my MyRIO is being listed out. Okay, so my MyRIO is being listed out. When I click on this, okay, when I click on this, yes, just watch it. You can do it later. Don't do it parallelly because this one procedure you have to follow for Wi-Fi connection. How to establish, because I'll make it again. From host, we connect to your RIO or RT system through either USB or Wi-Fi, right? So USB is pretty simple. I showed you how to do it. Now I'm trying to show you how to connect it through Wi-Fi. Only then it is going to be a proper IoT system. Okay, at least for that reason. Okay. So here in the system setting, you can see what is the IP of your MyRIO. It is 172.22.11.2. As usual, I told you through Ethernet. I mean Ethernet in the sense it's USB it mean actually. Okay, so you can see that through USB cable connection, through wire connection, it is 172.22.11.2. Okay. Now what I'm going to do is, and this is what I told you, right? This is the ARM processor Cortex 7 version. Okay, so ARM processor Cortex 7 version. Okay. So at the bottom we have system setting, right? You can go to the network setting because I want to establish a network and configure a network. Okay. At the bottom you can see there is system setting. Actually currently you are in system setting. Okay. Currently you are in system setting. From system setting move to your network setting. Okay. Move to a network setting. Okay. In network setting you have two types of categories. Okay. Number one category is network adapter, which is, I mean, under network adapter you have Ethernet adapter USB type. Okay, that's a primary connection, source connection. And secondary you have wireless adapter, LAN. Wireless LAN. Okay, you can see the wireless LAN. Basically it will be disabled. Don't do it, just watch here. Okay, so what I'm going to do is I'm going to enable it. Okay, so here it is disabled, right? I'll click on this. There are three options. One is disabled, one is connect to a wireless network, which means that if you have an existing network, your MyRIO can connect to that network. Okay, even your computer can connect to the network. That will act as a gateway, and these all will act as a nodes, as I showed you in the previous slides. Okay, so now what is going to happen is I'm interested to create any network here. I don't think so. We have Wi-Fi connection also, but your MyRIO actually have a ability to generate a Wi-Fi. Okay, so it generates a Wi-Fi. You can't surf it. Basically what you can do is you can just only establish a connection. That is all you can do it. So what I'm going to select is I'm going to select create a wireless network. Okay, I'm going to create a wireless network. Okay, and country, I told you, right, each and every country has its own band range. Okay, at least for that reason you are supposed to select your country. I'm going to select my country name, India. Okay, and SSID is nothing but, it is a, watch, I can do it later, that's what I'm telling you, just do it later, just prepare your attention. So say here, say it will be disabled, say you want to create a network and you will find all these options getting enabled. Okay, select India. Okay, after this MAC address, don't try to make any changes. It's a physical address you have for the hardware. You can never make any changes. Just keep that. Don't do anything. SSID is nothing but the network which is going to be to that, right? So this network is going to get, broadcasted. Okay, this network should have a name. What I'm going to give a name is okay, or I think everyone will keep this name. So I'll give my institution name. Okay, so I'll just name it as VI Solutions, my institution name, for example, because there are 10 MyRIOs here, so everyone will go to there now. So try to have a unique name for yourself, okay, because you'll be connecting with other people if you mismatch it, okay. So or you can give a Wi-Fi password for this, okay. So here channel, I always believe we used to get better output on the 10th channel, but you can have anything. Frankly speaking, you can have anything, but it's fine to give a channel number 10. Okay, so security you can give open or you can give a personal security password. You know what is this, right? For any Wi-Fi you can have a password. When I click this, it will allow me to give a password. As of now, I'm not interested to do those things. because let me leave it open network, so anybody can connect it if you want it, okay, for your purpose, okay. So here, configure your IPv4, okay. This, make it into DHCP only, okay. So dynamic, let it be more dynamic, so I mean just make it DHCP only, okay. So these are the settings you have to make it, okay. So create a wireless network, your country name, and the name for your, it can be anything without any space. Don't try to give any space, okay. So you can give any SSID. SSID is the name of your network, okay. Give any name, and channel, make it 10, that will give a better output, and then go for security is open. You can give some password if you really want. Make sure it's case sensitive, make sure when you do it properly. And IPv4 configuration, make it DHCP only, okay. Apart from that, this IP address and everything is not yet configured yet. Once you say save at the top, once you do all these changes, say change at the top. Don't try to go for certificate manager and everything. Usually what we have is we have a habit, do everything, at the last we have save, or we'll save it here. No, don't do that, okay. At the top we have save, okay. Click save here, okay. Click save. You can see it is saying broadcasting VI solution. No one is broadcasting VI solution. The network name is VI solution, okay. So it's broadcasting this network, and now you can see that the IP address is configured. Before it was 0.0.0, am I right? Now you can see it is configured. What is the IP now? 172.16.0.1. Here what is the IP? 170.22.11.2. So if you are connected through, I'll just move a little up. If you are connected through LAN, okay, if you are connected through LAN, when I say LAN, it's USB here, okay. When you are connected through LAN, okay, the IP is going to be 172.22.11.2. That's a default IP, you'll get it, okay. Even you people will get the same. If you are connecting through a Wi-Fi, okay, the IP address will be 172.16.0.1. For verification, you can go to the system setting and you can check here. You can see now wireless is also added, okay. So wireless is also added, you can see that. So through Ethernet, which means that USB, it is 172.22.11.2, and if it is wireless, it is 172.16.0.1. Fine. Is it happening? Once it is happening, it should tether. You can see the Wi-Fi button here. MyRIO has a Wi-Fi button, am I right? Third one, Wi-Fi button should glow, which means that it is tethering a network. For checking it, what we can do is take your phone and switch on your Wi-Fi. Switch on your Wi-Fi. Don't connect anything because it's open network. Don't connect it as of now. Don't connect it. Okay. You have to see a network in the name of VI solution. I can see. There are many networks. Okay. But I have VI solutions also. Okay. So 50-meter range, I think everyone can see that. Yes, you can see that. So now it has started tethering it. And if you have seen this, don't connect it for kind information. Switch off your Wi-Fi and put it back. Okay. To just see whether it is tethering. Checking through your network. Okay. So now since it is there, watch here. I can connect it here also. You can see VI solution is available for my computer. This is the reason I want you all to use your laptops. Okay. So you can see that VI solution is being shown here also. What I'm going to do is I'm going to connect it here. Okay. So connect it automatically. Let it connect automatically to this computer. No issues. You don't try to select it because I told you that number of nodes you get connected to which is limited. Okay. So maximum for a better efficiency you can connect 6 to 7, not more than that. So don't try to connect everyone. Okay. I'll just say connect. Okay. So it is connecting. Okay, at the bottom you can see that it is connected to VI solutions. It is connected to VI solutions. You can see this. Okay, so which means that your hardware is properly connected. Okay, and one more thing, the problem is, what is the IP address of your host? When I say host, what is that? Your gateway. Okay, what is the IP address of your gateway? What is the IP address? 172 dot. What is the IP? 16.0.1. Why 16.0.1? Why not 22.11.2? Because we are trying to configure wirelessly. Okay, so this Wi-Fi connection is established through wireless. Okay, so at least for that reason you should prefer the Wi-Fi IP. Okay, Wi-Fi IP you are supposed to prefer. My host Wi-Fi IP is 172.16.0.1. Okay, as of now. Okay, what you are supposed to do is make sure your computer, right click on this, open, right click on the Wi-Fi symbol. At the bottom you have Wi-Fi symbol, right? Yes, right click on this Wi-Fi symbol, open network sharing. Okay, open network sharing. Okay, in this you can see that no internet connection, okay, no internet access, but it is connected to Wi-Fi. The name is VI Solution. Okay, I'll click on this. Okay, and I'll go to properties. Watch here, I'll go to properties. I'll select IPv4 because we are using IPv4 only as of now. Okay, so I'll go to properties again. IPv4's properties I go. Make sure this will be obtain IP automatically. Even here DNS also obtain server automatically. Okay, the reason is now my computer is connected. My computer, it can have some x.x.x.x IP. My computer might have. Okay, now it is connected to this network. Okay, since it is connected to the network, if it want to communicate, your computer IP should be in the range of this or in the series of this or something like 172.16.0. Some X number except 0, because already one is being occupied by my server. Except 1, I can use any other number. Okay, so it varies from 0 to 255, you know this. Okay, it can take any value from 0 to 255. Okay, so let us be in the safer side, leave it, obtain IP automatically. If you really want to say, use the following IP only, you have to type the value according to the series. Okay, so I don't know how many of you can do it without having mistake or something. Let's just be in a safer side, always say obtain IP automatically, that's better. Okay, and say okay. Okay, so done. So if this is happening, okay, if this is happening, you can see it's connected and running also your MyRIO at the bottom. So I'll minimize my max. This is the use of the max to configure your MyRIO wirelessly. I've configured it. Okay, any doubt in this configuration? Any doubt in this configuration? No? If that is the case, make sure if you're using a laptop, make sure it connects. Okay, make sure it connects. Okay, so meanwhile, I'll show you the procedure how to start up LabVIEW. Okay, once again you have different procedure to start up with LabVIEW. Okay, so establish a connection. At least make sure your Wi-Fi will trigger a network. Okay, finish that. I'll come and help you out. So we'll go to the next step because one more big procedure is there. You want me to repeat something? Anything you want me to repeat? So go to Max. Go to Max. Okay, under remote system, you will have the MyRIO listed out if it is connected through LAN. Through USB. Okay, click on this and go to the network setting, create a wireless network and do all these changes and say okay. Okay, after doing this, your MyRIO will trigger your network. Okay, it will broadcast. Go to connect your laptop. If you're using a laptop, connect it to your MyRIO. Okay, once you connected it, right click on the Wi-Fi symbol, open network sharing. Okay, right click on your Wi-Fi symbol, open network sharing, click on your Wi-Fi. Okay, click on your Wi-Fi connection, properties, IPv4, once again properties. Okay, and select obtain IP automatically. Say this and say okay. Okay, so that is all you are supposed to do right now. Okay, do this and be ready. We'll start up with LabVIEW. And shall we have lunch by 1:15? Is it fine? It's nearly 5 minutes to 1, so we'll take 20 minutes now. So we'll finish this and we'll move. Okay, yeah. And meanwhile, once we come back from lunch, at least 1 or 2 people take the app which I'm telling you. I have in my phone. I'll just share it to you. So we'll just try to work on that. Okay, connect it. You don't have a laptop? Oh, you can take my laptop. Okay, you can use it. Here. Do you have laptop, sir? Yeah, laptops here. This is not installed. Okay. So everyone have connected your laptop to your MyRIO network? Yes? Everyone done this? Okay. Watch here. Now what I'll do is I'll once again create a project. The same way how we do it, right? Create project. Okay. Yeah. What's the problem, sir? Yeah, this broadcasting side is done. What you're supposed to do is, you connected LAN, right? I just have to now remove this. Remove. No, click and yeah. So remove it. Okay. So VA solution. This is yours. Okay. Connect it. Okay. Connect your computer to this. Okay. It is connected. Right click on this. Open network sharing. Okay. So here, properties, IPv4 properties. It is all correct. Okay. So that is all. Close. And minimize this and start with lab. Okay, close this also, nothing there. Okay, blank project, create project. Okay. Yeah. So what you're supposed to do is, you're supposed to say, this is the version we have. Okay, anything you can install. I'll just install 15. Okay. I'll say next. You can say next. That is all. It will do. Once it is installed, you can just. Just watch here. I'll just show a demo on this. Okay. So once again, go to blank project and say finish. The same normal way of what do you do it. Do the same. Okay. You have to add a MyRIO to it. Even that's the same procedure. Right click, new, targets and devices as you do in the previous method. Okay. As of now, if you see, my computer is connected to my Wi-Fi. My computer is connected to my Wi-Fi, but even it is connected to my cable also. Okay, my computer is connected in two methods. Okay, let it be. I'll expand my MyRIO. Okay, it shows this is being listed out. One hardware is being listed out. I'll click on this and say OK. Okay, so it's already connected, so it is showing it is being listed out. Okay. So it discovers chassis, but here you can see. Watch here. This is very important. Watch here. So what is the IP address it is taking? MyRIO IP address is 172.22.11.2. It means that this is established using USB. Okay, it is established using USB. You can see here my USB's IP. I'll just go to system setting here. My USB's IP is 172.22.11.2. But what I need, wireless I need, it is 172.16.0.2. Am I right? So what I have to do is, watch here. Okay, right click on this MyRIO. Before you connect, don't connect it. Right click on MyRIO. Go to properties. This is a very important step. Okay, right click on MyRIO, go to properties. Okay, here what is IP? It says 172.22.11.2. What we need? 16.0.1. That is the IP which I really need. Okay, so you personally go and change it. Okay, you sometimes it will list out two hardwares. There you will have 172.16.0.1. Select, then it will connect. Okay, like how I was showing the morning session might show like that. Sometimes you will not get it. I'm really happy that it was not showing. I'm showing the what is the actual step you are supposed to do for this. Okay, so you go and personally change it to the required IP. Fine. So now right click on this and say connect. Now right click on this and say connect. You can see it is connected successfully. And now since it is connected successfully, you will not be needing the USB connection anymore. Okay, from now you will not be needing the USB connection anymore. You can keep this in a very remote place also within the range of this Wi-Fi. Okay, your laptop is already connected, only the power supply I have right now. The cable I have removed it. Excuse me. So now it is communicating and you can see it is connected also. Okay, what I'll do is I'll keep it somewhere in remote like this. Okay, I'll keep it remote. Okay, far away from my computer. I just kept it away from my computer. Okay, watch here. So what I'm going to do is I have already done a program, right? This IR sensor program I have already done, right? So what I'll do is I'll right click on my RIO. Usually we say new VI. Am I right? This time I'm going to say add file. Excuse me. So add file. The one which I have done is, where is IR? Okay, IR acquire. This is the VI I just did. I'll select this and I'll add it. So you can see I added this into my RIO. Double click on this. Okay, so I'll run this code. Same code. You can design the new code if you really want. The same code. Acquire. Do the same connection for your IR sensor. How I did it. Do the same connection. Okay. But previous time how it was communicating? Through USB. This time it will be communicating through Wi-Fi. Good. So I'll save this. I'll close it. It is acquiring. Okay. So if you see, there is no actual connection between my computer and my RIO physically. Okay. There is a virtual connection through network. Okay. So you can see that this is my sensor. Okay. So any changes I try doing it. I can power it even keeping it somewhere little far inside the range. LAN. Okay. Wi-Fi range. Okay. So any changes I make, you can see that it is plotting on my computer, but there is no connection between my computer and my RIO. But they are transmitting and receiving through a Wi-Fi connection. Getting it? So any changes I do here, it will be listed out there. You understanding this? Okay. What I'm going to do now is, I'm going to show your procedure again from the first. Okay. I'm going to show the procedure again from the first. I mean the LabVIEW code. Okay. For this I have to establish a USB cable connection. First of all, what I'm going to do is I'm just going to establish a USB cable connection. I'll connect it. I'll say do nothing. I'll stop it. I'll close this. Okay. I'll even close this. Let me take a fresh one. I don't want to save this. I'll take a fresh one. Okay. So create project. Create project. All blank project. Finish. Okay. Right click on your project. Okay. New targets and devices, the same way how we usually used to do. Targets and devices, and we have my RIO, expand my RIO. Your hardware should be listed out here. Your hardware is being listed out here. But usually when there is a primary connection and a secondary connection, I have a primary connection of LAN, I mean USB, and a secondary connection of Wi-Fi which is being already established, but it always prefers the primary connection. Okay. So I'll just say okay. So you will find that your hardware will get connected to the, okay, here already since it was connected like this. Okay, for you people, it will look like, how it will look? 142.22.11.2. This is how it will look like for you people. Okay, this is how it will actually look like. Okay, so once you connect it, this is how it actually look like. Okay, so what you have to do is, you have to right click on this my RIO once again. Okay, go to properties and make a change on this. What is the IP? It's a desired IP 16.0.1. Okay, why my computer was preferring the Wi-Fi addresses? I never disconnected it. It already was connected. Above that, one more connection is not possible. If both are not connected, okay, and when you're trying to connect it, the primary address will get connected. Like for the first time when it happened, right? The same way. Okay, so change it to the IP address of your default wireless connection. Okay, so okay, yes, so it will get changed to it, and right click and say connect. You should find that this has to glow. This has to glow here. When it glows, you can see the deployment is also successful. And say close. Okay, so and say close, and you can right click new VI. You can design a new VI you want, or if you already have a VI which has already been done, you can just go to add, file. This time let me try doing a accelerometer test. Okay, I'll go for accelerometer, add file. So double click on that accelerometer VI, so it opens. Oh, it's too big. Just reduce the size. Yes, I'll keep it inside the screen. I'll run this code. It'll ask me to save. I'll save it. Yes, it is deployed and is acquiring 3 axes like how we did yesterday. Accelerometer code which we did yesterday, right? I show you the code also. X, Y, and Z accelerometer, bundle them together and plot it on the chart. This is what we saw yesterday. Okay, so same code. I'm just adding it into this project. And now, if you see any changes I make, is it working? Any changes I make, it's working. But how it is connecting? Through LAN or through Wi-Fi? It is Wi-Fi. So which means that I don't need LAN. Am I right? Sure. It is not needed exactly. Okay. So I can remove this. You can see usually when you remove that, what do you get here? Connection loss. You will get it. You will usually get connection loss when it is Wi-Fi. Wired connection. Now you can see it is only my power connection for my cable. For my processor you need a supply. Okay. So any changes I do, is it working there? Yes. So because they are the data are transferred to my laptop wirelessly. Okay. This is what actually IoT technology will be there once you have an actuator sense. Depending upon this, if you can control many more things. You have one more motor here, let me say, depending upon this data, it goes there and comes back and communicates, okay, then it is actual IoT comes into picture. We'll try doing it once we come back from lunch, yes. So, but what I want you all to do is, I want you all to install a software, an app into your computer, your phone, okay. So I'll just share it, I'll just share it to one person or 2 people, okay, you can circulate it among your friends, okay, your colleagues, okay, that will be fine, yes. So as of now, what I'll do is I'll just stop this code. Don't try to abort it. Always try preferring stop button. Yes. I'll just display this. Go to properties and this is the changes you have to do. Okay. So once it is connected, you can't make any changes. Okay. If it is connected, watch here everyone. Right click on this. Right click on this, properties, you try to change it, right? That will not happen if it is connected. What you are supposed to do is right click on your My RIO, disconnect it first of all. Disconnect it, then right click and then say properties and make any changes you want. Once it is connected, you can't make any changes to the IP. Disconnect it virtually on the software, through software, and then make a change and connect it back. Clear? Any doubt in this? And I want you all to repeat the same once again with a task. Okay. Now what is the task I really want you to do is, watch here. So I have this sensor, right? I have this sensor which is connected. Okay. Wirelessly what you are supposed to do is, if I bring my hand closer, these LEDs should glow. Morning I gave you this task, am I right? I think no one has completed it yet. Okay. Try actually is developing now. Okay. So when it is little far away, it has to switch off. When I come closer, it has to switch on. When I take it away, it has to be controlled. The sensor and actuator, LED is actuator here, okay. So try doing this. This is the application I want you to develop. That should be possible because yesterday I showed a demo on mark and how much mark secured, mark obtained based on that, is it a pass or fail we are trying to show, am I right? The same application I want you to repeat, but with different logic. Getting it? Yes? So we'll go for lunch within 5 minutes, try to complete this and we'll just wind up for the lunch here, yeah? So finish this hands on. I'll just move to your places and I'll help you out if you need help.